Hello, welcome to a quick video on setting up and translating a quadratic function. So at first, we're going to look at translating standard quadratic functions. The parent graph, f of x equals x squared. Now one way of doing it is the basic table. What I'll go ahead and do is to put in a few values. I have x and I have f of x. Now generally I want to find out the values from -2 to +2. So -2, -1, 0, 1, and 2. Now I want to do -2 squared, which is -2 times -2 or +4. -1 times -1 is +1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. If I added another value, 3 times 3, which I might need later, is 9. Now to plot these points, I'll just go to my x-axis, to the left 2 and up 4. 4. To the y-axis, to the right left 1 and up 1. My vertex here is 0, 0. To the right 1 and up 1. To the right 2 and up 1, 2, 3, 4. I might as well put a 3 in, and 3 and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And -3 is also 9. Another way I can do it is this is 3 away, so I'll go 3 more, 1, 2, 3. So my basic graph is going to look as follows. You try to make it nice and smooth. And you want to show the arrows because they go continuously. Okay? Now a couple things we want to point out in the course of this. This value right here is known as the vertex. It is where the parabola changes from one direction to the other. Now you should notice that you have equal points on either end. So I'm going to put a dotted line or a dashed line that goes above that. That is known as the axis of symmetry. We can reflect one side off of the other. And the next thing we want to see is how do we make a shift from there? So if I use this basic table a couple of times, and let me go ahead and copy this so I can use it again. Now on my next page, what happens if I want to shift it left or right? Actually, what I wanted to do was show you another page, and I'll paste this back in. And I want to first shift it up and down. Up or down. Okay? So let's say if I have this, f of x equals x squared plus 3. Well, all that can mean is a couple of things. The thing we want to look for is what's going on to the whole function. I am adding 3 to every x squared value. So I could just go next to the original table and add 3 more to each one. So f of x plus 3, so next to 4, I'll have 7. I add 3 to 1, and I get 4. 3, 1 plus 3 again is 4. 4 plus 3 is 7. 9 plus 3 is 12. Now for that graph, so if I start that one, I can go ahead and plot those points. Now what I'm noticing is, right here seems to be where it goes down and starts back up again at 0 and 3. So here's 0 and 3. So 1 if I go to the 1 and 4, 1, 2, 3, 4. Or I can go, then I go 2, and then it is, my value for 2 is 7. 1, 2, 3, 4, 5, 6, 7. And then, if I did my axis of symmetry, straight up here, I can take each point and count 1 and 1. 1, 2, 1, 2. And then I'll go ahead and draw this line. It's not really a line, it's a curve. Okay? Now I don't always want to have to use a table. I want to double check something instead. What if I pretended that this was my 0, 0 point, my vertex? This first point is to the right 1 and up 1 from that spot. This next point will be to the right 2 and up 4. And if I had room, I could have done 3 and 6 from that vertex point. Now the vertex of this value is 0 for x and 3. Now my axis of symmetry if you're asked to name it, anything along the x-axis, this value is 0, x is 0 here, it's also 0 up and down here. So the axis of symmetry is this line, x equals 0. Notice that this matches that. It's the same as the h value. Okay? So, now the next thing, what happens if I have it go, let's say I took the same exact graph and wanted to shift it in a different direction. So let me move a couple of things here. Probably not that. Well, if let's say that I have f of x equals x squared minus, let's say, 8. Based on this idea, this minus 8 means I'm going to go down 8. Now, as we get better at this, we're going to recognize the vertex. The x is not grouped, so I know the x value is 0 right on the that y-axis. The k value is negative 8. So I'm going to count down 8. 1, 2, 3, 4, 5, 6, 7, 8. There's my vertex. Now let's try using our relative 0, 0. Since the shape is exactly the same on this one as it is on the parent graph, if I go here, I count 1 to the right and up 1, that's 1 point. If I count 2 to the right and up 2, 1, 2, 3, 4, excuse me, up 4, I might as well, as long as I have the room, let's do 3 and 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the axis of symmetry is our dotted line, which goes straight up from the vertex. So here, I counted 1 over. I'll count 1, 2, 1, 2. And now I'll take my 9th point, 1, 2, 3, 1, 2, 3. So this one will look like this. Sorry if it cuts into the words there a little bit, folks. So that's x squared plus 3. Now I want to double check the shape of this. Or let's not for right now. I'll check it in just a second here. Let me go to the next slide. If I want to shift it left and right. When x is grouped in the h, the x value of the vertex will be the opposite sign from the grouping. Let's take this example. I have x minus 3. Within the grouping, I see that it's x minus 3. Now officially you could say this, x minus h equals x minus 3. You subtract x from both sides and you'll have negative h equals negative 3. We now know that h equals positive 3. There's a number of ways of doing that. That's just one of many. Now, there's no number following this. There could be an invisible plus 0. So I know my shift is going to be 3 to the right. From the parent graph. So my vertex will be 3, 0. Let's plot this. So to the right, 3. And there's my first value. Now I want to use my parent graph idea, my relative 0, 0. So that means I go 1, 1, 2, 4, 3, 9. To the right 1 and up 1. To the right 2 and up 4. To the right 3 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. And I want to use my axis of symmetry, which comes straight up from the vertex. And I'm going to count from that side. I'll count 1, 2. Well, 1 and 1. This one is 2 and 2 more. This one is 3 to the axis, then 3 more. So here's my parabola. The parabola's giving me a little bit of trouble. Let's see if I can do it again. Can't quite get it. Okay, so my parabola is going to look like this. Don't know why it doesn't seem to like me right now, but that's okay. I'll draw it in a sec. Okay, here's my parabola. Or not. Okay, so I finally got the parabola drawn. It wasn't pretty, but it should work okay. Now let's do another one real quick. What if I said this? F of x equals, quote, x minus 4 squared. Actually, I want to say plus 4. Now in this case, another way of finding the vertex is to look inside the grouping, and your h value is the opposite. So I know it's going to go 4 to the left. There's nothing being added at the end, so I have 0. So I'm going to graph that very quickly. 1, 2, 3, 4 is my vertex, and my relative 0, 0. 1 and 1, 2 and 4, 3 and 9, 5, 6, 7, 8, 9. My mirror points will be across the axis of symmetry. 1, 2, 3, 1, 2, 3. So this doesn't look exactly like that. Now, if I took this same exact graph, this shape, if I cloned it, moved it down, yeah, I could change colors on it just for simplicity. All right, let's say I wanted to go 3 to the right and down 5. That would be my graph right here. So if that vertex is 3, negative 5, my function would look like this. F of x equals, it was going to the right 3, so I say minus 3, square it, minus 5. Thank you. That's all for now.